Hello and welcome back at the second session of Protocols and Models. At the first session of Protocols and Models, we discussed about the rules of communication, and as an analogy, we compared the communication between human network and devices network. And we will go further with the topics of protocols, protocol suites, and the reference model. And for each of them, we will discuss in the slides that will come next. We know that each end devices that is connected over a network to communicate must agree the same set of rules. And these rules are called protocols, and they have many functions in network. Network protocols define a common format and set of rules for exchanging messages between devices. Protocols are implemented by end devices and intermediary devices in software, hardware, or both. Each network protocol has its own function format and rules for communication. And then we will have a table with the various types of protocols that are needed to enable communication across one or more networks. And we will have network communication protocols, where protocols enable two or more devices to communicate over one or more networks. The Ethernet family of technologies involves a variety of protocols such as IP transmission control protocol, called as TCP, hypertext transfer protocol as HTTP, and many, many more. We will have even the network security protocols, where protocols will secure data to provide authentication, data integrity, and data encryption. Examples of secure protocols include Secure Shell Protocol as SSH, Secure Socket Layer Protocol as SSL, and Transport Layer Security as TLS. We also will have routing protocols, where these protocols enable routers to exchange router information, compare path information, and then to select the best path to the destination network. Examples of routing protocols may include Open Short Path First Protocol as OSPF and a Border Gateway Protocol as BGP protocol. And lastly, we will have the Service Discovery Protocols. And these protocols are used for the automatic detection of devices or services. Examples of Service Discovery Protocol include Dynamic Host Configuration Protocol as DHCP, which discovers services for IP address allocation, and Domain Name System as DNS, which is used to perform name to IP address translation. Network communication protocols are responsible for a variety of functions necessary for network communication between end devices. And as you can see in the figure, there is the sender that needs to send a message to the destination over the network. And he will say that I will send this message across the network using an IPv4 header. And the intermediate devices will understand this because they say that I can forward this message because I understand the IPv4 header that you are sending the message, and also the message will be delivered to the receiver at the destination, and he will say that I can accept the message because I understand the IPv4 header. And so we must know that computer and network devices use an agreed upon protocols to communicate. And the table of the protocols is the addressing, where with this we can identify the sender and the intended receiver of the message using a defined addressing scheme. Examples of protocols that provide addressing include Ethernet, IPv4, and IPv6. We will also have the reliability. With this function, we will provide guaranteed delivery mechanism in case messages are lost or corrupted in transmit. So the TCP protocol will provide guaranteed delivery. And we will have also the protocol about the flow control. And with this function, we will ensure that the data flows at the efficient rate between the two communication devices. And still, for this, we will have the TCP protocol that will provide flow control services. We will also have the protocol about sequencing. And with this function, we uniquely will label each transmitted segment of data. The receiving device uses the sequencing information to reassemble the information correctly. This is also if the data segments are lost, delayed, or received out of order. And still, the TSP will provide the sequencing services. We will have even an error detection, and this function is used to determine if data became corrupted during transmission. Various protocols that provide error detection include Ethernet, IPv4, and IPv6, including even TSP protocol. And at last, we will have the application interface, and with this function, we will contain information used for process-to-process communication between network applications. For example, when accessing a web page, HTTP or HTTPS protocol are used to communicate between the client and the server web process. A message sent over a computer network typically requires the use of several protocols, and each one with its own function and format. In the figure, there shows some common network protocols that are used in the communication between two devices, and in this case, there is a device that will send a request to the web server for accessing a web page, and the protocols that are used here are the HTTP protocol, so the Hypertext Transfer Protocol, and with this protocol, we will govern the way a web server and web client interact. An HTTP protocol defines the content and formatting of the requests and responses that are exchanged between the client and the servers. Both the client and the web server software implement HTTP as part of the application. The HTTP relies on other protocols to govern how the messages are transported between the client and the server. So, the message that will transport them is the Transmission Control Protocol as TCP protocol. And this protocol manages the individual conversation. The TCP protocol is responsible for guaranteeing the reliable delivery of the information and managing flow control between end devices. We will have even the IP protocol, the Internet protocol, and with this protocol, we have to know that this protocol is responsible for delivering messages from the sender to the receiver. The IP protocol is used by routers to forward the messages across multiple networks. And the last protocol that is used in the communication between the devices and the server, in this case, is Ethernet. This protocol is responsible for the delivery of messages from one network interface card to another network interface card on the same Ethernet local area network, so in the same LAN. And as you can see, these protocols are layered. We will discuss further that they are layered depending on the TCP/IP model protocol. In many cases, protocols must be able to work with other protocols so that your online experience gives you everything you need for network communication. A protocol suite is a group of interrelated protocols necessary to perform a communication function. One of the best ways to visualize how the protocols within a suite interact is to view the interaction as a stack. A protocol stack shows how the individual protocols within a suite are implemented. The protocols are viewed in terms of layers, where each higher level service depending on the functionality defined by the protocols shown in the lower level. The lower layer of the stack are concerned with moving data over the network and providing services to the upper layer, which are focused on the content of message being sent. As an analogy, we will see the communication between humans. So, we will describe the communication face-to-face that is occurring between those two guys. At the bottom, there is the physical layer where we have two people communicating with their loud voices, where they are saying their words. In the middle, there is the rules layer that are suitable for the requirements of communication, including that a common language must be chosen. So we use a common language, we have to wait for the other turn. So every time we say the word, we have to wait for the other to respond, and we have to give a signal when we are finished. So, and at the top layer is the contact layer, and this is where the contact of the communication is actually spoken. In this case, is where is the cafe. So with this, we understand that the protocol suites are a set of rules that work together to help in solving a problem. The TCP/IP protocols are available for three layers: application, transport, and internet layers. And there are no TCP/IP protocols in the network access layer. The most common network access layer for the LAN protocols are Ethernet and wireless LAN protocols. Network access layer protocols are responsible for delivering the IP packets over the physical medium. And as it is shown in this figure, we have the example of three TCP/IP protocols that are used to send packets between the web server and with a host. The HTTP, TCP, and IP are the TCP/IP protocols that are used, where the HTTP is for the application layer, TCP is for the transport layer, and the IP is for the internet layer. At the network access layer, in this case, we are using the Ethernet protocol. But however, this could be also a wireless LAN protocol or a cellular service. Here in this slide, we have an animation that demonstrates the complete communication process using an example of a web server transmitting data to a client. And the first one, so this is the data that need to go to the client. So that is the user data. And as we go to the TCP, so we started from the application layer, we went to the transport layer, which is we added the TCP header And then we went to the IP layer, Internet Protocol layer. So we added even the IP address, and then at the Ethernet layer, it transferred that into signal, which the signal will be in bits, and will go to the client. So this process is the process of the encapsulation, which means that the data in each layer that go from the application to the Ethernet layer and then transferred into the signal, it is added as the header of each layer. So in the transport, we added the TCP protocol header. So the data with that header is called a TCP segment. Then we at the Internet Protocol layer, we added the header of the IP address, and it is called the packets. And then we added the header of the Ethernet, which it is called the Ethernet frame. Then the frame is converted into signals and transferred to the client. And at the second animation, we have the opposite, is the decapsulation this time. So the client got the Ethernet frame, and then it will read the IP, which means that the packet is for me. We'll read the segment, and then we will send at the segment we'll check if there is any error or no, and then we'll send that segment to the application layer, who will understand the data, and then this is what the client will see. So it is the same information that was at the web server. So these were the TCP/IP communication process, the process of encapsulation from the server to send to the client, and the process of decapsulating the information that he got from the server to be understood for the client. Actually, we cannot watch the real packets, how they are traveling across a real network. So for us, it is helpful to have a way of thinking about a network so that we can imagine what is happening at the network. And for this, it is useful to use a model. Complex concepts such as how a network operates can be difficult to explain and understand. And for this reason, a layered model is used to modularize the operation of a network into manageable layers. And these are the benefits of using a layered model to describe network protocols and operation. The layered model will assist in protocol design because the protocols that operate at a specific layer have defined information that act upon and defined interface to the layer above and below. Another benefit is that it will foster competition because the products from different vendors can work together. And another benefit is that will prevent technology or capability changes in one layer from affecting other layers above and below. And the last benefit that we can say is that we'll provide a common language to describe network function and capabilities. And as it is shown in this figure, there are two-layer models that are used to describe the network operation. We have the open standard. We have the Open System Interconnection Reference Model, which stands for OSI Reference Model, and the TCP/IP Reference Model. And as you can see, the OSI model has 7 layers, and the TCP/IP model has 4 layers. And as you can see, the application, presentation, and session layer at the OSI model is merged in one layer and the TCP/IP model, which is the application. Anyway, we'll discuss for them in the next slides, but as you can see, these are mentioned in the middle, even the protocols that are used in each layer. So at the OSI model, the application, presentation, and session layer, even the application and the TCP/IP model, use the HTTP, DNS, and DHCP and FTP protocols. And at the transport layer, they use the connection-oriented layer, then connectionless layer, which it is a TCP for the first one and UDP for the second one, and even the protocols for the other layer that we discussed even the slides before. So we will continue further with the first model, so with OSI reference model, and we will describe each layer and the function of them. So as we say that we will go through the reference model, which is the OSI model, and it is a reference model because it provides an extensive list of functions and services that can occur at each layer. This type of model provides consistency within all types of network protocols and services by describing what may be done at a particular layer, but not prescribing how it should be accomplished. It is also describe the interaction of each layer with the other layers directly above and below, and the TCP/IP protocol discussed in the later are structured around both the reference model and the TCP/IP models, and the table will show the function of each layer, and the functionality of each layer and the relationship between layers will become more evident through the topics that we will discuss in the later videos, because we will discuss for each layer properly. But for the moment, we will say not in many details, but only the basic. The application layer, we send for the 7th layer at the reference model, is the layer that contains protocol used to process communication. And the 6th layer, which is the presentation layer, provides the common representation of the data transferred between application layer services. The 5th layer is the session layer, which provides services to the presentation layer to organize its dialogue and to manage data exchange. The 4th layer is the transport layer, and will define services to segment, transfer, and reassemble the data for individual communication between end devices. At the network layer, will provide the service to exchange the individual piece of data over the network between identified end devices. And the 2nd layer is the data link layer. The data link layer protocols that describe the method of exchanging data frame between devices over a common media. And the 1st layer is the physical layer, where the protocols here describe the mechanical, electrical, functional, and procedural means to activate, maintain, and deactivate physical connection for a bit transmission to and from a network device. So, where the TCP/IP model layer are referred to only by name, the 7 layers of the OSI models are more often referred by the number rather than by the name. So we usually the 7th layer, but we do not say the application layer. So they are mostly known by the number of the layers and not by the name of the layers, because the name of the layer are more common used at the TCP IP models. The TCP IP protocol model, it's the inter-network communication and sometimes is referred to as the internet model. This type of model closely matches to the structure of particular protocol suite. The TCP IP model is a protocol model because it describes the function that occur at each layer of protocol within the TCP IP suite. The TCP IP is also used as a reference model, and comparing to the OSI model, it has only 4 layers. And as we said before, in the TCP IP model layer are known by the name, comparing to the reference model OSI that is mostly known by the number of the layer. So the layers here are the application layer, who represent data to the user, plus encoding and dialog control. The third layer is the transport layer, who support communication between various devices across diverse networks. And the second layer, which is the internet layer, determines the best path through the network. And the network access layer, who is the first layer, will control the hardware devices and media that make up the network. So in this layer, in this model, there are 4 layers, and as you saw a couple of slides before, the 3 layers of the OSI model were merged into 1 layer. So it was the application, presentation, and session layer merged as one as application layer to TCP IP protocol model. And we saw even that the network, it's called different, it's called internet here in this model. And we saw even that the data link and the physical layer at the reference model OSI is merged to the network access layer at the TCP IP protocol model. And we will discuss even the comparison between those 2 models. That will be in the next slide. The protocols that make up the TCP IP protocol suite can be also described in terms of the OSI reference model. In the OSI model, the network access layer and the application layer of the TCP IP model are further divided to describe discrete functions that may occur at these layers. At the network access layer, the TCP IP protocol suite does not specify which protocol to use when transmitting over a physical medium. It only describes the handoff from the internet layer to the physical network protocol. OSI layers 1 and 2 discuss the necessary procedures to access the media and the physical means to send data over a network. And the key similarities are in the transport and network layers. However, the 2 models differ in how they relate the layers above and below each layer. OSI layer 3, the network layer, maps directly to the TCP IP internet layer. This layer is used to describe protocols that address and route messages through an internetwork. The OSI layer 4, the transport layer, maps directly to the TCP IP transport layer 2, and this layer describes general services and the functions that provide ordered and reliable delivery of data between source and the destination host. And the TCP/IP application layer includes several protocols that provide specific functionality to a variety of end users application. At the OSI model, layers 5, 6, and 7, as we said before, are used as a reference for the application software developers and vendors to produce applications that operate on a network. Both the TCP/IP and the OSI models, OSI models, are commonly used when referring to protocols at various layers, because the OSI model separates the data link layer from the physical layer, and it is commonly used when referring to those layers. So these are the comparison between those two layers. And for the moment, thank you for being with me at the second session of protocols and models, and waiting forward to see you with the two other topics at the third session, where we will discuss about the data encapsulation and data access. And for the moment, thank you for being with me again, and please do not forget to subscribe at my YouTube channel AA Networking and hit the button notification to notify you for the new videos that are coming each Monday. Thank you and see you soon.